Okay, so wrapping up example page 6.3 here, which is a couple more examples. So example 3 and example 4. And example 3 again, we're going to calculate the sun's mass, noting the period of the Earth's rotation around the sun is this many seconds, and the distance from the sun is that distance. Again, this is a prime example of we're actually going to assume that the Earth is following a circular orbit unless they tell me otherwise. So again, they don't reference the elliptical orbit here, so I'm going to go ahead and assume that it is a circular path. But I am going to take advantage of the period, right? So they give me the time, and therefore they're giving me the period. And I know that the period of orbit for the Earth, in orbit, is 2 pi times the square root of r cubed over gm. So the biggest thing I have to be comfortable with is what do all of these measurements represent? Well, I know the period. They actually gave me the period is 3.156 times 10 to the 7th seconds. I know 2 pi is obviously just 2 pi. I know the radius, the distance they give me from the Earth to the Sun is 1.496 times 10 to the 11th, and we'll go ahead and assume that that does include both radius of the Sun and the Earth, right? Because technically we'd need from the center of the Earth to the center of the Sun. So we'll assume that that distance does include all of those measurements, since they didn't give me the other information here. So again, I know that total distance, 1.496 times 10 to the 11th, and then cubing that whole thing. So just be careful as you calculate this, right? And then my universal constant, 6.67 times 10 to the negative 11th times the mass of the sun. So obviously at this point we've got all the measurements except the mass of the sun. We just need to be careful about doing our algebra, right? Make sure when you divide both sides by 2 pi you include that in parentheses so you don't accidentally divide by 2 and then multiply by pi. And then just be careful about using your parentheses here. But anyway, I'll leave the algebra to you guys to try it, but you should get the mass of the sun to be about 1.99 times 10 to the 30th kilograms, which is very accurate for what our current calculated mass of the sun is. So anyway, hopefully this example is not too bad. Again, if you have trouble with the algebra, let me know, but I will assume that you guys are pretty confident with it. Okay, so example 4 here, I'll leave it to you guys to actually do a lot of the calculating, but obviously I'll help you set it up. And the key concept here is, what does this term geosynchronous mean, right? Well, geosynchronous says it remains at the same place over the Earth's surface as the Earth rotates. And so that actually becomes a very key part about this problem, right? They ask us how fast is it going, so we want to end up finding the velocity. But again, what information does this help me determine? Well, if it's geosynchronous, if it stays in the same place over the Earth as the Earth rotates, then here's my Earth, right? So as the Earth is rotating, as the Earth is spinning around, this satellite is staying exactly above it as it turns around. So how long does it take the satellite to complete one revolution, right? Well, if it takes the Earth 24 hours to spin, then it takes the satellite 24 hours to complete one revolution. So in other words, my period is, right, 24 hours. So 24 hours would be 24 hours times 60 minutes times 60 seconds, right? So we can calculate that number and go from there. Well, that period ends up being 86,400 seconds, right? So we've got that information. So the question becomes, okay, what can this help me solve? Well, this can help me out because, right, if I think of the period equation, if I think of the period formula, it'd be 2 pi times the square root of r cubed over gm, right? So I've got that. It also, though, I'm going to have to go back and reference the mass of the Earth, right? So we saw that in a previous problem. It's 5.98 times 10 to the 24th. So once I know the period, I can use that period to help me find out the height, the total radius, the total distance that the satellite needs to be placed in orbit with. Right, so again, I'm going to leave that to you guys to calculate. You can find, though, that total r, that total height, from the center of the Earth to that satellite's position. So you're going to find that total r. And then from there, right, if you want to find the velocity, well, again, velocity is just 2 pi r divided by t. Well, we already know the period, and we just found the r, so at this point it would just be a matter of 2 pi r, so 2 pi whatever that number is, divided by t. So again, I'm going to leave the rest of you guys to go ahead and calculate. Obviously double check with yourselves to make sure you guys all agree with each other as well. But hopefully this question doesn't give you too much trouble. If it does, certainly come find me, but I think this is one you guys can probably coast your way through without too much difficulty. So anyway, that finishes section 6.3. Section 6.4, excuse me, and 6.5 do get a little bit more challenging as well, so please make sure you guys are paying close attention in each of these videos.